you. Okay.
I don't understand it, how you gave it all away. Don't know how you managed to keep holding it down for me. Goodness and mercy, it's all me, it's all me. And your love is my favorite, unchanging. Billie Jean both inside, got a joy I can't deny it. Something got me feeling right, heart is like an open fire. This time of year, we can't forget. Gave the gift. And the first day of Christmas, you gave it all up. Ain't that some real love? Ain't that some real love? You won't need a wish list, got all that I want. You gave me real love. You gave me real love. Real love. Real love. I don't understand it. You never give up on me, love everlasting. So I'ma let the whole world see
your unmask and your patience, so good and so gracious. No lie when I say this, feel like you were built inside. Got a joy I can't deny it. Something got me feeling right, heart is like an open fire. This time again, we can't forget. Ooh.
Your blessings around me, it's the best gift under the tree. Yeah. What more do I need? When I got you, I feel complete. I can feel your presence around me, it's the best gift under the tree. Yeah. And the first day of Christmas, you gave it all up. Ain't that some real love? Ain't that some real love? You don't need a wish list, got all that I want. You gave me real love. You gave me real love.
How do you mend a broken world? Give it a gift it could never earn. Pour out a love that it don't deserve. Send it a son and a savior. It was a silent night, a holy night. All was calm and all was bright around young virgin, mother and child, holy infant, so tender and mild. Hush, hush, I hear the clouds speak.
It's the advent of Cyber 2023, and we are on a mission to save Christmas. McGreedy, you are going down. I have the THM Army with me. Let's go. Yeah. I'm a Papa Shell, but not what you think. Who am I root? Make it dead a leg sink. We are on a mission, we're here to save Christmas. McGreedy's going down, forget about the riches. Rumors gone around like Skitty's got snitches. It's an insider threat and everyone's suspicious. Recon McRed is hunting down a witness. He says he needs our help, so power on your system. Get your black hoodie, boot up the attack box. Hackers come together and take command of the SOC. It's the THM army. McGrady will get caught from the 0x1 all the way up to the gods. And it is time. What is up, everyone? Welcome back to my live stream. My name is Tyler Ramsby, and we are on a mission to save Christmas. Don't even have my Christmas stuff on. We have the black hoodie on. We are ready to do some hacking. So, hey, guys, if you've been here before, welcome back. If this is one of your first times joining me, hey, welcome as well. It's an honor to have you taking the time to hang out and learn alongside of me. Just a few things before we dive in. For those of you who've been here before, none of this is new to you, but for those who might be stumbling across this for the first time, I do not prep these things ahead of time. So as I'm doing these Advent of Cyber challenges, this is my first attempt at the challenge, and I read through everything in its entirety. I think when we skim, we miss stuff. So we're going to read through all of it together, work through the scenario together, and see what we can learn. And today, at least based on the name, we are learning about SQL injection, or SQL injection if you want to say it incorrectly. I call it SQL injection. So without any further ado, let me share my screen and let's go ahead and dive right in. So here is a story. The Best Festival company started receiving many reports that their company website, bestfestival.thm, is displaying some concerning information about the state of Christmas this year. After looking into the matter, sent to Security Operations Center, the SOC, hackers take command of the SOC, right from the song, right? Confirmed that the company website has been hijacked and ultimately defaced, causing significant reputational damage. To make matters worse, the web development team has been locked out of the web server as the user creds have been changed. With no other way to revert the changes, Elf Exploit McRed has been tasked with attempting to hack back into the server to regain access. After conducting some initial research, Elf Forensic McBlue came across a forum post on the popular black hat hacking internet forum Jingle Hacks. This post, made earlier in the month, explains that the poster is auctioning off several active vulns related to the Best Festival company systems. And here it is. From Gridster, which we can all guess is McGreedy. Hello, Jingle Hacks forums. As the merger of Best Festival company approaches, I find myself in a position of knowledge that's as good as gold. I decided to auction off these vulns to the highest bidder. The stakes are high, the potential rewards are even higher. If you've got the skills and resources to make use of this information, you're in for a serious payday. I won't reveal all the details here, but I can confirm that these vulns are both 0 days and known issues the Best Festival company hasn't addressed. The treasure includes potential entry points, data access, and even the possibility of exposing classified information. To bid, reply to this story with your offer. I'll provide a secure channel for the winning bidder to transfer payment. The Greedster. Whew. This forum post surely explains the havoc that has gone on over the past week. Armed with this knowledge, Elf Exploit McRed began testing the company website from the outside to find the vulnerable components that led to the server compromise. As a result of McRed's thorough investigation, the team now suspects a possible SQL injection vulnerability. All right. Hey, before I go any further, let me make sure I'm not missing anything in chat. I want to say hello to Jaso or Justin. He is always here, but he's starting a boot camp. So this will be one of his last times joining live. But yo, Justin, good luck with the boot camp. Think you'll have fun. Looking over at Twitch, we have 8-Bit Oni and Justin again on Twitch. So good to have you guys here. I know we have a few other people on Twitch. Let me refresh LinkedIn since I always have to refresh it to see chat. Make sure I'm not missing one on LinkedIn. All right, we are good. Let's continue working through this. So what are our learning objectives for today? Well, number one, learn to understand and identify SQL injection vulnerabilities. Number two, exploit stack queries to turn SQL injection into RCE. And finally, help Elf McRed restore the Best Festival website and save its reputation. Now, I have already booted up my attack box and the VM, so we have the IP there. Blah, blah. SQL, structured query language. It is essential for working with relational databases and building dynamic websites. Even if you've never explicitly used SQL before, chances are you frequently interact with databases. Whether you're checking your bank account balance online, browsing through products on an e-commerce website, or posting a status on social media, you're indirectly querying and altering databases. SQL is one of the most popular languages that make all of this possible. Relational databases are structured data collections organized into tables, each consisting of various rows and columns. Within these collections, tables are interconnected with predefined relationships, facilitating efficient data organization and retrieval. For example, an e-commerce relational database might include tables for customers, orders, and products with relationships to find to link customer information to the respective orders through the use of identifiers. We see customer ID connects to customer, product order connects to product ID. SQL provides a rigid way to query, insert, update, and delete the data stored in these tables, allowing us to retrieve and alter databases as needed. A website or application that relies on a database must dynamically generate SQL queries and send them to the database engine to fetch or update the necessary data. The syntax of SQL queries is based on English and consists of structured commands using keywords like select, from, where, and join to express operations in a natural, language-like way. We'll leverage an example of a database table to represent the tracking and cataloging of Christmas tree ornaments. The table and column structure might look something like this. In the example above, we have a defined database table, which I don't think actually shows us that, but the table itself must be called table ornaments, to store ornaments with various columns that provide characteristics or qualities related to each item. We can run various SQL queries against this table to retrieve, update, or delete specified data. And even if you've never looked at SQL before, I bet you can understand what is going on here. So select, we have a wildcard, which means select everything from table ornaments where material equals wood. So if we go here, we're looking at the entire database and we're looking at, hey, where does material equal wood? It's right here. So it's going to pull out this entry right there. And here's another one. Select ornament ID, color, and category. So we're only looking at ornament ID, color, and category. I always think it's helpful to read this out as you do it. From table ornaments, which is the name of the overall table, where the elf ID equals 102. So what this is going to select for us is the ornament ID of 3, the color of green, and the category of tree. And let's see, blah, blah. We're doing insert, so we're adding something. So insert into table ornaments, and then we're specifying all of the columns, the ornament ID, elf ID, color, category, material, date created, and price. And what values are we passing it? Well, it's going to be the ornament ID of 5, the elf ID of 105, the color of blue, the category of star, the material of glass, the date created of that, and finally the price. This insert statement adds a new ornament, etc., etc. PHP. So PHP is a popular general-purpose scripting language that plays a crucial role in web development. It enables developers to create dynamic and interactive websites by generating HTML content on the server, and that's the key. PHP is server-side code, so keep that in mind. Server-side versus client-side. If you're doing a pen testing interview, they might ask you the difference between server-side and client-side code and to give an example. So an example of server-side code would be PHP. It interacts directly with the server, so if you can exploit it, you can get RCE on the server. Client-side code would be more JavaScript, where you can exploit the client or the customer visiting the website. PHP, like I was just saying, server-side scripting language. Okay, I think I answered that for the most part, but that's how we can execute SQL queries and all that stuff, because it has to go back to the server. The most common way for PHP to connect to SQL databases is using the PHP Data Objects extension or specific database server drivers like MySQLi for MySQL or SQL Server for Microsoft SQL Server. The connection is typically established by providing parameters such as the host, username, password, and database name. After establishing a database connection, we can execute SQL queries through PHP and dynamically generate HTML content based on the return data to display information such as user profiles, product listings, or blog articles. Returning to our example, if we want our PHP to fetch information regarding any green-colored ornament, we can introduce the following lines. So here's our query. Here's our parameter. Select everything from table ornaments where color equals green. Result equals SQL query. And then we have our connection. That's how we're connecting to the SQL database and the query. Now, if we just back up, the way that SQL injection is inserted into this is, let's say where color equals green, let's say this field accepts user input and it doesn't validate it in any way. Well, if that's the case, we can inject, essentially we can close this out. We would inject really these characters, and then we can do our own SQL query after that, going into SQL injection. So I'm sure they'll show it to us, but that's kind of how you spot it in code. In the above snippet, we first save our SQL query into a variable named query. This query instructs a database to retrieve all rows from the table ornaments table where the color column is set to green. We then use a SQL server query function to execute this query by passing a database connection object. You can think of the result variable as a container that holds the outcome of the SQL query, allowing you to iterate through the rows and access the data within those rows. Later in the script, you can use this result object to fetch and display data, making it a crucial part of the process when working with databases in PHP. Justin over on Twitch said wildcard. Thank you. That's what, yeah, wildcard. You got it. And hey, Z is back. He said this is a fun room. Awesome. I'm looking forward to it. User input, exactly what I was just talking about. While the ability to execute SQL queries in PHP allows us to interact with our database, the real power of database-driven web apps lies in making these queries dynamic. In our previous example, we hard-coded the query to fetch green ornaments. However, real-world apps often require users to interact with the data. For instance, let's imagine we want to provide users with the ability to search for ornaments of their choice. Well, in this case, we need to create dynamic queries that can be adjusted based on user input. One common way is to take user-supplied data in web applications is through GET parameters. These parameters are typically appended to the URL and can be accessed by PHP. They allow users to specify their search criteria or input, making it a valuable tool for interactive web apps. We could create a simple search form with an input field for users to specify the color of ornaments they want. Upon submitting the form, the website makes a GET request, etc., etc. So, before we scroll down, let's look at this. We have this color, get color. So this is taking straight user input. We're not doing anything special with it. We're not parameterizing it. We're not encoding it. Like, we're just taking straight user input, and then we're passing that user input here. Okay, so when you see that, you should be able to spot the vulnerability. What if in our color for user input, we do quote, a double quote, and then that, and then we do our own SQL injection. We're essentially escaping this and doing our own SQL query to the database. The above snippet sets the color variable to the retrieved value of the color URL parameter. That variable then gets passed into the query string. Now, users can dynamically control the query being executed by the database simply by modifying the URL parameter they include in their request. For example, color equals green. This simple example shows how powerful PHP and SQL can be in creating rich dynamic websites. But introducing SQL injection. Taking in user input, supplied input, gives us powerful ways to create dynamic content, but failing to secure this input correctly can expose a critical vulnerability known as SQL injection. SQL injection is an attack technique that exploits how web apps handle user input, particularly in SQL queries. You see, instead of providing legitimate input like the ornament color in the example above, the attacker injects malicious SQL statements into a web app's input fields or parameters. The application's database server then executes this rogue SQL query. Now, SQL injection vulns pose a considerable risk to web apps as they can lead to unauthorized access, data theft, data manipulation, or even the complete compromise of web apps and its underlying database through RCE. If an attacker can control which queries the database execute, they can control the database functions, perform the data return. As such, the impact can be catastrophic, ranging from exposing sensitive user information to causing significant data breaches. SQL injection vulns continue to be highly pervasive despite numerous advancements to mitigate them. And I'll just say, we do see this. It's not all the time, but we do come across this in real web apps as we're doing pen tests. But when I discover a possible SQL injection in a web app, the way I test it in a pen test is I don't dump their database. You have to be very careful with SQL injection, because if you do it wrongly, you can corrupt their database. So what I'll usually do is do command execution with sleep. So I'll make it like sleep 10 seconds, sleep 20 seconds. And if I can consistently make the application sleep with SQL injection, then I'll report it to the client. And then I'll ask, hey, do you want me to dig in further, or is this enough? Because really, they don't need me to dump the database on a time-limited pen test, different than a red team engagement. They just want to say, hey, is it here, and should we fix it? So I demonstrate it by making it sleep, saying, yes, it's here. If you want me to demonstrate it further, then we can use things like SQL map, and maybe we'll get a chance to show that off. When a web app incorporates user input into SQL queries without proper validation and sanitization, it opens the door to SQL injection. For example, consider our previous PHP code for fetching user input to search for ornament colors. Right? There it is there. Without adequate security measures, an attacker can manipulate the color parameter to execute malicious SQL queries. For instance, instead of searching for a benign color, they might input that as the input parameter, which should transfer the query into this. So select everything from table ornaments where color equals that, or 1 equals 1, which is true, and then we're going to comment out the rest. In other words, it's going to return everything. As the query above shows, blah, blah, the OR is part of the injected code, where OR is a logical operator in SQL that allows for multiple conditions. In this case, the injected code appends a secondary where condition in the query. 1 equals 1 is a condition found in the OR operator. This condition is always true. And so, since 1 always equals 1, blah, blah, that at the end is a comment, just like I said. It tells the database server to ignore everything. The condition color is empty, and the OR 1 is always true, effectively making the entire where condition true for every row in the table. As a result, the SQL injection system manipulates the query to return all rows from the table ornaments table, regardless of the actual ornament color values. This is a classic example of a SQL injection payload, where the attacker leverages the OR 1 equals 1 condition to bypass any intended conditions or logic in the query and retrieve data they are not supposed to access. A caution. Let me check out chat. Am I missing anything? Oh, Z said, normally these reverse shells fail, but it worked in this room, felt like a hacker. That is always a good feeling. One time, so I've only been a pen tester for a year, guys, and getting full RCE isn't very common in real pen tests, but one time in the past year, I had full RCE via a shell on like a production web app. I felt like a real hacker when that happened. When I did Who Am I and I saw the result. Fun stuff. A caution around OR 1 equals 1. Okay, there's an entire room on Try Hack Me created by the one and only Tiberius that demonstrates this. It's crucial to emphasize the potential risk of using the OR 1 equals 1 payload. While commonly used for illustration, injecting it without caution can lead to unintended havoc on a database. I think it's called Lesson Learned. If you want to check it out, it's Lesson Learned ? I actually have a whole YouTube video of me working through it live. The intention is typically to bypass authentication or return all items in a table by making the condition always true. However, the risk lies in that you might not be aware of the context and scope of the query you're injecting into. Additionally, applications may sometimes use values from an initial request in multiple SQL queries. SQL injection payloads that return all rows can lead to unintended consequences when injected into different types of statements, such as update or delete. Imagine injecting it into a query that updates a specific user's information. An OR 1 equals 1 payload would make the condition true for every row, leading to a mass update affecting all users in the table. This lack of specificity, there we go, I said it right, specificity in the payload makes it a risky choice for pen testers who might inadvertently cause significant data loss or alterations. You don't want to be that guy or that gal. A safer example would be a more targeted condition based on a known attribute identifying the record you want to manipulate. For instance, Bob and 1 equals 1 would update Bob's record, while Bob and 1 equals 2 would not. This still demonstrates a SQL injection volume without putting the entire table's records at risk. Hey, there it is. Check out that room. Like I said, if you get stuck on here, I have an entire walkthrough video of, not even a full walkthrough, it's me just going through it live, like demonstrating my thoughts, kind of like how I do this and me going through it. So make sure you check out that video. It's on my YouTube if you just search through it. Fortunately, the dev team behind the Best Festival Company has confirmed that the website does not run any unpredictable queries and has permitted us to use this payload to demonstrate the vulnerability. Stacked queries. SQL injection attacks come in various forms. A technique that often gives an attacker a lot of control is known as a stacked query. You see, stacked queries enable attackers to terminate the original query and execute additional SQL statements in a single injection, potentially leading to more severe consequences such as data modification and calls to stored procedures or functions. In SQL, the semicolon typically signifies one statement's conclusion and another's commencement. This feature facilitates the execution of multiple SQL statements within a single interface within the database server. It's important to note that certain web app technologies and database management systems may demand different syntax or lack support for stacked queries. Consequently, enumeration is essential for precision when conducting injection attacks. So, suppose our attacker in the previous example wants to go beyond just retrieving all rows and intents to insert some malicious data into the database. It can modify the previous injection payload to this. So we're closing it out, then insert in a table ornaments we're just adding something there. When the web app processes this input, here's the resulting query. Select from table ornaments where color equals, and then we're ending the query, kind of like I was talking about up above when I was just looking at the code, and then we're inserting that into it. So testing for SQL injection. Testing is a critical aspect of web app security assessment. It involves probing the application to identify vulns where an attacker can manipulate user-supplied input to execute unauthorized SQL queries. To continue our mission, let's navigate to the Deface Best First Couple website. Let's go to it. Blah, blah. From here, you should see the Deface website. And we'll try to just do this without even looking at it. So welcome to Santa's workshop. Welcome to our mischievous elves, blah, blah. Christmas has been canceled, just like DEF CON. Oh, no. We do not apologize for any inconvenience. Not the evil elves. All right. Must be the gift search. Okay, so we see all that going through. And what we can do, I'm just going to make this full screen, guys. Give me one moment while I fix this real quick so I can make it full screen. All right, here we go. Malware keeps it odd. Tyler's doing my ALC room, only slightly nervous. Oh, sweet, dude. I'm glad. Thanks for joining. Really appreciate you being here. I've read through everything so far, and I'm going to try the SQL injection, though, without looking at how to do it. So generally, and I'm sure the room explains this, we'll go back to the room once I am done playing around with it myself. When it comes to SQL injection, one really easy way to check is you just do a single quote and see if you get a 500 error or a SQL error, which we can already see this. Usually it's not this verbose, but sometimes you'll just get a 500 server error, which is a really good sign that, hey, this might be vulnerable to SQL injection. And it's also how we identify like which spot is vulnerable. So are all the fields vulnerable? Or is it just budget? Let's check. Oh, so all the fields are going to be vulnerable to it. Okay, so good to know. We identified the SQL injection vulnerability. Let's go back to the room. The underlying PHP code is taken in the three parameters we specified for age, interest, and budget as separated by the ampersand character, and creating the database to retrieve the filter results. Got it. Now that we've identified an area of the website where user input is accepted, we can test if it's vulnerable. To test the fields, we can submit characters like that, which is what I did in double quotes, as these are special characters that attackers use to manipulate SQL queries. We might be able to trigger error messages by introducing possible syntax errors in the query and prove that the input is unsanitized as it reaches the back end. However, the gift search feature doesn't offer any free-form text inputs, so we can look at modifying the URL parameters directly, which is exactly what I did, and we got our error message. Must be a flag there. I don't even know what that error was. Oh, maybe it just asks like what version or what is the error. And like I bet if we do this, I thought that might fix it. We can see that it's trying to convert it to data type integer. So we have a lot of information on this backend database. The error received is a huge breakthrough as it gives us many details in the underlying database server. The error shows us Microsoft SQL Server. The information we gather will soon be helpful. Error message enumeration is critical to SQL injection testing because it equips attackers with valuable information for crafting more precise and effective attack payloads. Because of this, it's always essential to monitor and sanitize error messages to prevent sensitive information from leaking. And this goes beyond just SQL injection. Like on a pen test, even if the server, like often if you go to the like 404 not found page, you go to a fake page, it will return the version information of the underlying web server. On an actual pen test, we'll report that to a client as either an informational or a low, depending on if there's known CVEs for it, and just say, hey, you don't want to return version information on your web application. Even if the version is not vulnerable now, it just gives attackers more information about the tech stack that might be running. So we always encourage people on pen test, always return generic messages there. Always return generic messages on login, on password reset, on account registration. Everything should be generic. Don't give attackers any way of discovering information about your tech stack on the back end. All right, although we don't have access to the source code at this point, we can visualize what the underlying PHP script might look like. And we can. So we have get age, interest, budget, and then select name from gifts where age equals age, interest is equal to interest, and budget is greater than or equal to budget, or less than or equal to budget, I should say. So if we just look at this, before we go on, I want you to answer the question, why is this vulnerable to SQL injection? Think about it for a second. What we do to fix SQL injection is what's called parameterized queries, is one way of fixing it. And what we're doing here is we're literally just taking the user input and querying directly with the user input. So if we're passing this here, we can quite easily escape this input, and then we can do our own query. So we could escape on the budget side of it. We could do single quote, this, another query, and then comment, kind of like what we saw above. As seen above, the script is likely extracting the values from the URL parameter in an unsanitized way, directly inserting them in the SQL query to be executed. If we break out of the hard-coded query by injecting our own SQL syntax, we can manipulate the request and consequently the return data. Let's attempt to do it. So we're doing OR. Now, just want to remind you guys, on a real pen test, you don't want to do OR usually, and the room author, which Malware Cube, did a good job explaining this. And once again, I would recommend this lesson learn room by Tiberius, because if you end up like me, you end up doing OR and then you end up having to reset the machine because you break it. Which it's better to break a CTF and learn the lesson than do it in a client's real environment. And, you know, that's not going to be good for you or the client when you have that question there. But we are going to do OR because it said that we talked to the elves and they said, hey, we're not passing this to any other queries, so it's safe to do OR and see how it goes. So let's give that a shot. Well, let's do it manually ourselves. Right? So OR 1 equals 1, and then we're going to comment it out. And then you can see it's returning everything to us right here. Now remember, let's go back, because I know SQL injection is hard to understand. So why does this work? Well, if we look at this get thing, we have to remember what we're doing when we are passing to this is we are doing, really closing this out, and then OR 1 equals 1, so it's always true. And then all these other queries, so if we go to age, all these other queries right here, it's not even considering that because of this comment thing. So if you think about comments in HTML or any other language, it's saying ignore everything that comes after this. So although this query is still technically here, it's being ignored because we're commenting it out. So it's just returning to us all the data because 1 equals 1, of course, means true. By injecting our payload and commenting out the rest, okay, so exactly what I just said, we have dumped the database table and returned all 300 or 636 rows of the page. Simple example, etc., etc. So calling stored procedures. As mentioned, stacked queries can be used to call stored procedures or functions within a database management system. You can think of stored procedures as extended functions offered by certain database systems serving various purposes such as enhancing performance and security and encapsulating complex database logic. A Microsoft SQL Server stored procedure XP command shell is a specific command that allows for executing operating system calls. If we can exploit a stacked query to call it a stored procedure, we might be able to run operating system calls and obtain remote code execution. As we previously confirmed, the database system in our example is Microsoft SQL. With that in mind, let's dive deeper in XP command shell. Yes, and for those of you studying OSCP, make sure you know this. There's a flag at the bottom. Oh, is there? I'll probably just come back to it. Oh. Oh, I see. There's a flag. I'll grab that for now. I also want to introduce you guys to SQL map and how we can do some of this as SQL map. What are our flags? Oh, here's the one. All right, we have a lot of work to do, it looks like, on the flags. I'm excited for that. So XP command shell. This is a system extended stored procedure in Microsoft SQL Server that enables the execution of OS commands and programs from within SQL Server. It provides a mechanism for SQL Server to interact directly with the host OS command shell. While it can be a powerful administrative tool, it can also be a security risk if not used cautiously when enabled. Because of the known risks involved, it's recommended that this functionality is disabled on production servers and is by default. Now, Now, think about an internal pen test, though. Often on an internal pen test, that's like an assumed breach scenario where you're given a set of AD creds and maybe VPN access to the client's environment. Often you will encounter SQL servers that have this enabled, and you're able to use that to really get full access of that server, maybe to dump hashes and move laterally within the network. So keep that in mind. However, due to misconfigurations on legacy apps that require it, it's common to see it enabled in the wild. For example, suppose you have an HR management system that needs to export data periodically to a CSV file and upload it to an external server. Instead of using more secure and modern methods like SQL Server integration services or custom application code, legacy apps may have opted to rely on XP Command Shell to execute system-level commands to export the data. While this accomplishes the same task, it poses security and maintainability risks and grants excessive system access to SQL Server. Remember, the principle of least privilege applies not only to employees, but to systems themselves. It is also possible to manually enable XP Command Shell and SQL Server through the execute queries. Still, it requires the database user to be a member of the sysadmin fixed server role or have the alter settings server level permission to execute this command. However, as mentioned previously, misconfigurations that allow this execution are not too uncommon. We can attempt to enable it on the Best Festival Company database by stacking the following commands using the SQL injection we discovered. By injecting it, we'll first enable advanced configuration options in SQL Server, right there, by setting show advanced options to 1. We then apply the change to running configuration via the reconfigure statement. Next, we enable XP Command Shell by setting that to 1, and then we apply the changes. Converting this into a single stack SQL payload will look like this. So once again, we're escaping our really age 1, and we're saying, hey, we want you to execute this new query, and we're doing the exact things it says up there, but at the end, we're just doing that because that's proper SQL syntax. Otherwise, it will error out. I am just going to copy it this time, but I think you guys get the point there. Let's see if it works. Okay, I think it's a good sign. Unfortunately, one of the caveats is that it returns its results as a rows of text. Oh, this means that typically the output will never be returned to the user since the injection no longer occurs in the original intended query. Interesting. Because of this, we're often in the dark as to whether our injection worked, but there are ways to validate whether or not our approach is working. Let's confirm if we have remote code execution by attempting to execute certutil.exe in the target machine. This command is a native Windows command line program, and I use it all the time to transfer HTTP stuff. In our scenario, we can use it to make HTTP request to download a file from the web server we control. To set this up, let's create a malicious payload using MSF Venom, allowing us to eventually upgrade our SQL injection shell into a more standard reverse shell. Now we can go back to sharing our screens here. There we go. XP command shell. Okay, I just read that, I think. Here we go. So first, we're going to create this payload with MSF Venom. I'll kind of walk you guys through it as I do it. Let's get our terminal open. And we will zoom in. Okay. Hopefully my head's not in the way. Matter of fact, I'll make myself a little bit smaller. You guys don't need to see me that much there. Now I'm just a little tiny guy in the box, in the bottom right corner. Okay, so MSF Venom is a way to generate a wide variety of payloads. I always forget the syntax, to be honest, when I do this. So I'm always looking at the MSF Venom cheat sheet just because I don't do it super often. But even for those studying for the OSCP, this is allowed. Metasploit's not allowed, but you can use MSF Venom to generate payloads. So -P is saying, hey, here's the type of payload we want to specify, and we know it's Windows. Now, how do we know it's Windows? Well, we know it's Microsoft SQL Server, which means it's running on a Windows server, so we know it's Windows. We can do x64, and then shell reverse TCP, and then we want to do our L host, which is RIP, so our attack box. Mine is 10.10.221.250. But hey, if you're new and following along, just know that your L host is going to be different than mine. An easy way to see it if you're on the attack box is right there. You can see your L host on the attack box, and that's our listening IP. Our L port, we can't just do the standard 444. And then -F is saying, hey, what do you want to output this file as? Well, we want it to be a Windows binary, which is exe, so we can execute it. And we do -O, reverse. I always like to include the port in my reverse shell, especially on CTF, so I remember what port is listening on. So I'm going to call it reverse-4444.exe. Should not take too long. All right, yep, we'll host our listener. We'll also open a tab here. We'll start our listener, so that's ready. MSF Venom shouldn't take too long. There we go, we got it. Okay, and now we're going to host a very simple Python web server. And we'll listen on port 8000, just like the instructions say. And now if we go back to this, we have hopefully enabled full commands. So what we're going to do is escape our query, and then we're going to execute xp command shell, and then we're going to go ahead and give it the command. So cert util url cache -f. We're going to give it RIP 10.10.221.250. Remember, we're listening on port, we're not listening, our web server is on port 8000. We're listening on port 4444, and our file is called reverse 4444.exe, and we want to save it to Windows temp reverse 444.exe. And then we have to comment out the rest of the SQL query. Now, I typed it. There's always a good chance I have a typo. Fingers crossed. Let's see what happens. Okay, so we don't see any results here, but if it worked, we should see an HTTP GET request to our web server, which there is. So we know that our victim, which look at our IP, 10.10.45245, did a GET request for our reverse 4444.exe. So we know that XP command shell is enabled because it properly executed that command. Okay, etc., etc. We've achieved RCE, netcat, control C, and now we're just going to go ahead and execute this. And we just have to literally go to it. Windows temp reverse 4.exe. Comment out the rest. Whoops, there we go. Hopefully the web page loads. It's a good sign. That's not my thing. Let's go over here. Pull it up. Hey. And we have full reverse shell on this machine. And I'm actually, before we even restored the website, guys, I want to show you, well, I guess even when we restore the website, we find out we're not going to fix the SQL injection, are we? All right, hey, I'm actually going to pause here. Let's show off SQL Map. SQL Map is a way to automate this, but you should, so a few caveats on SQL Map. You should know how to do it manually. First of all, don't just rely on automated tools. And two, if you're studying for the OSCP, SQL Map is not allowed on the exam. So do not become overly reliant on SQL Map for discovering or exploiting SQL injection, especially on the OSCP, because you are not allowed to use it. So let's open a new tab. Do we have SQL Map on the attack box? We do. Okay, beautiful. Yeah, I'll zoom in for you guys. So I'll show you an easy way I'd like to use SQL Map, although we can just pass it the URL because it is in the URL. But often your SQL injection parameter is not right here in the URL. It'll be elsewhere, like in the post request. And I'll show that to you guys. The way I like to do it is to use Burp Suite. Where's Burp Suite on here? All right, I'll pop open Burp Suite and I'll show it to you guys. And actually, let's make this full screen again. Do this. There we go. Give it a second to load. Want to make sure I'm not missing anything in the chat. All right, I don't think so. Zoom in that window. Okay, got you. Got you, bro. Temporary project. Start Burp. Yeah, Burp now, Cato later. I want to install Cato this time just because the only thing I'm using Burp for is to capture the request. It actually isn't needed for this SQL injection because it's in the URL. But like I was saying before, often the SQL injection is in a post request in the body, and there's a really easy way to pass that to SQL Map, and I want to show it to you guys. So intercept is on. Let's just go back out to the website. There's that. Okay, good. We'll turn burp on, and we'll go back and actually turn intercept for now. All right. GIF search. Let me click it. Start my GIF search. And we'll do child, toys, budget, and we'll go back over to burp. We'll turn on intercept, and we'll hit search. That'll bring it over to burp here. And what I would do is I'd pass it over to repeater and say, hey, let me just test for basic SQL injection. And you can see just like before, we have our SQL injection there. And then if this isn't a body though, it's a little more difficult to exploit with SQL map unless you specify things properly. So let me show you the script kiddie way of doing it. We're going to go ahead and copy our request, the full thing, go back to our terminal, and we're going to nano, and we're going to call it request.text. Pass it there. I think that weird spacing is fine. I think. Actually, I might have to fix that. Let's just take away the extra spaces. I don't know if it matters, to be honest. And now if we do SQL map, we can do -R, I believe it's -R, to pass it our request. And if our SQL injection was in the body, it would automatically discover that. So we can do that. Oh, whoops. Let me fix that. It doesn't like it when you have like tested variables in that. So I'll just fix that real quick. And it's going to do a lot of it for us. It tells us what the back end is. Do you want to skip payloads? Yeah, we can skip it. Do you want to include all test? Yeah. And you can remember like what the room explained to us. It actually tells us some of the things that it's checking. We're doing some stack queries right here, commenting. Get parameter appears to be Microsoft SQL, stack queries, injectable, which is exactly what we did manually. We can even get a shell, guys, with SQL map, and I'll show that to you as well. The parameter age is vulnerable. We can skip testing the other ones. Okay, so we know that it's vulnerable. Now I do need to remember the SQL map syntax for everything. So here with SQL map, we know it's vulnerable. We could dump tables, we could dump all the different data and stuff like that. But we already turned on, yeah, so overall we already turned on command shell. So with that, I believe we can just go ahead and prompt and get an interactive operating system shell. So let's give that a shot. We'll pass it that again, and we'll do OS shell. Hey, what up, Kimberly? Thanks for being here. Guys, look at this. We were able to do a very similar thing, but using SQL map. So with SQL map, we could detect the SQL injection, and then we just got that OS command shell, and now we have full shell as well using SQL map, as well as doing it the manual way. So I showed you guys in this video how to exploit it via SQL map and how to exploit it manually. So I hope you found that helpful. I will zoom in on this one. Now, I don't even remember what all of our questions were. Let me go back to the actual challenge here for the room, and we'll throw this back to the side. Let's see. Restore the website. Now that we have gained interactive control over the web server, let's see if any clues might help us restore the site. Exploring the system's users is a good place to start. This holds documents, etc., etc. They're here. It's worth mentioning that another legacy misconfiguration has worked in our favor. Providing the SQL Server service account, we connected with administrator level perms on the system. This higher level of access may provide us with capabilities we need to investigate and rectify the issue. Navigate to the administrator folder. Blah, blah. Here we'll search the subdirectories for hints or files that will guide us restoring the website and saving the reputation. And so we have it right here. We have the restore website. And if we type that, like, what did it do to deface the website? We can kind of analyze this. Set source folder, that. Set destination folder, echoing, defacing all files and folders. Beautiful. And so we can just restore it, which we'll get to that if we do look at the note.txt. Oh, you have another flag there. Got it. I received your Bitcoin payment. Thanks again for the speedy transaction. After you gain access, you can deface the website by running the deface website. If you need to revert it, you can run restore website. Please delete this note. So how do we protect it? Well, you have input validation, sanitize and validate all user-supplied input to ensure it adheres to expected data types and formats, parameterize statements, I kind of mentioned this before, parameterize queries automatically escape user input, making it difficult for attackers, and stored procedures to encapsulate your SQL logic wherever possible. Guys, I think, now, my memory might be failing me, but I think in Advent of Cyber last year, there was actually a secure coding challenge where we exploited SQL injection and then we fixed the SQL injection. I am blanking on if that's for sure. So if anyone knows for sure, let me know. But that might be worth checking out because it actually teaches you how to code and fix the SQL injection, which I thought was cool because most things don't teach that. So be sure to check that out. All right, so what are our questions? Well, first, we know that this is a flag for something. Right there. Manually navigate the deface website to find the vulnerable search form. What is the first website you come across that contains the gift finding feature? giftsearch.php. Analyze the SQL message that's returned what OBDC driver is being used in the back end of the website, which actually, oh, we can, I guess, just go like this. Actually have that in burp. What ODBC? So what driver? Is it just driver 17? That doesn't fit it. Maybe it's ODBC driver 17 for SQL Server. I bet that's what it is. Okay, what is the flag you receive on the home page after restoring the website? All right, we restored it. Turn off burps intercept. Hey, and there's our flag. Yo, really cool room. A lot of fun. I don't know if our friend Malware Cube is still in the chat. He was on YouTube. He was the creator of the room. So Malware Cube, if you're watching this, yo, kudos. You did an excellent job on this. Really appreciated it and learned some good stuff in it. For the rest of you, hey, thank you for taking the time to watch. I hope you learned some unique ways of doing this, both the manual way and the SQL map way, with taking our request directly from Burp Suite and passing that to SQL map. Speeds up some time. You don't have to then specify the injection point. It's able to do it for you. And then we can drop down into that shell as well to get that shell again. So two different ways of doing it. And I'll just tell you guys, like, if you want to be a pen tester, it's always good to have multiple ways of performing the same attack. When I'm on an engagement, an assessment, or just a CTF, often your standard tools do not work. So you need to have that ability to think on your feet, think of what are some other ways I can perform the same attack? What are some other ways I can transfer files, or some of the ways I can get a shell? You need that almost all the time. So hey guys, thank you again for taking the time to join me. I just want to say, by way of reminder, I am doing this every night throughout the month of December as we work our way through Advent of Cyber. I will be live on Twitch and LinkedIn and YouTube at this time, 8 p.m. Central Standard Time. And as usual, I don't prep these ahead of time. We go into it live, share my honest thoughts, and struggle our way through it. And hopefully you learn something in the process. So guys, thank you for being here. Thank you, Malware Cube, as well, for making this room. And hey, I will catch you guys in the next one. See ya.